Assalamualaikum warahmatullahi wabarakatuh. My name is Akil Hafiz Senlongtian, number metric 2019293238. And today I'm gonna explain about experiment 4, F4. The title is Energy Losses in Pipe and Fittings. Objective of this experiment is to determine the losses in the pipe fittings related to flow rate and to determine the loss coefficients related to velocity head. And the third one is to compare the losses of energy head losses in a different configuration of pipes. The introduction for this experiment is the energy losses in pipe and fittings apparatus has been designed for students to investigation of energy losses in pipe bands and fittings as well as a gate valve. The equipment is mounted on a freestanding framework supporting the test pipe work and instrumentations. These pipe fittings include mitre band, 90-degree elbows, a swept band, a contraction, and enlargement. And this is the equation to find the HL. HL equal to K times V squared over 2G, in which K equal to loss coefficient, V equal to average velocity of flow in the smaller pipe, and G is equal to acceleration due to the gravity, which is 9.81 meter per second squared. 45-degree elbow and a 90-degree elbow. This is the diagram for the elbow fittings. Left one is the 90-degree elbow and right one is a 45-degree elbow. Band fitting. There is a two type band, which is a long band and short band. This is the diagram. Sudden enlargement, which is the velocity from smaller diameter to the bigger diameter. And for the sudden contraction is opposite for the sudden enlargement, which is velocity from bigger diameter to the velocity to smaller diameter. Apparatus for this experiment. Number 1, 45-degree elbows. This one. And number 2, contraction. Number 3, enlargement. And this one, number 4, 90-degree elbows. Number 5, water inlet connection. Number 6, 90-degree short band. And number 7, manometers bank. Number 8, gate valve. Number 9, a differential pressure gauge. And number 10, 90-degree elbow. And lastly, number 11, water drain connection. And this is the size of the pipe, which is a pipe enlargement section and fittings. For the procedure, first step is to place apparatus on bench, connect inlet pipe to bench supply and outlet pipe into a volumetric tank. Step 2, with the bench valve fully closed and the discharge valve fully open, start up the pump supply from hydraulic bench. Step 3, slowly open the bench valve until it is fully open. Step 4, when the flow in the pipe is steady and there is no trap bubble, start to close the bench valve to reduce the flow to the maximum measurable flow rate. Step 5, by using the bleed valve, adjust water level in the manometer board, retain maximum readings on manometers with the maximum measurable flow rate. Note, a lower flow rate will reduce the water level, while higher flow rate will increase the water level. Step 6, note readings on manometers and measure the flow rate with the volumetric tank. Step 7, repeat the experiment with a different flow rates. The flow rates can be adjusted by utilizing the bench flow control valve. And lastly, step 8, plot a graph differential piezometer head, different against a velocity head for each device and determine the loss coefficients.
Microsoft Excel is used to make the result table and the graph. This is the sample calculation for flow rate, velocity in small bore pipe, and velocity head. This is the sample calculation to find the differential piezometer. These are differential piezometer versus velocity head graph for all fittings.
The conclusion for this experiment, we can measure the losses through pipe fittings and then use these measurements to estimate the loss of energy coefficients for each fitting. The different experiment data theoretically equations are mainly due to human factors such as parallax error. The errors found seem to be mainly due to the difficulty to determine the friction coefficient, which is a function of the Reynolds number and wall pipe's roughness. We learned through this experiment that there is a hair loss in each pipe due to internal friction of the pipes. The, the experiment is accurate and gives us a good idea of the hair losses in pipe. Recommendation: there are a lot of possibilities for an experiment with having an error. So, therefore, it is recommendations are as follow. First, change to the new equipment and apparatus. And the second one is build the platform when attacking the parallax error. That is just from me. Thank you for watching.